Scene script. Have you ever wondered how our solar system came to be, or how planets are formed and evolve over time? This cosmic conundrum is one of science's most fascinating puzzles. The formation and evolution of planetary systems is a process as complex as it is captivating. At the heart of it all is the interplay of gravity and the condensation of dust and gas around a star. Imagine a colossal, swirling cloud of dust and gas suspended in the vast expanse of space. This is the birthplace of stars and their planetary systems. As gravitational forces pull these particles together, a star begins to form at the center, its heat and light piercing the nebulous cloud. Around this nascent star, the remaining dust and gas begin to coalesce, forming a disk. It's within this disk that the seeds of planets known as planetesimals are sown. These tiny bodies, made of rock and ice, start to collide and merge, growing larger over time. This is how planets are born. Now, this is just a simplified overview. The actual process is much more intricate and involves various stages and phenomena, such as the formation of a protoplanetary disk, the differentiation of planetary cores, and the eventual clearing of the disk. There are also different theories about this process. Some suggest that planets form quickly, in a few tens of thousands of years, while others propose a slower, more gradual formation over millions of years. Then there are those perplexing cases, like the interstellar object Oumuamua, that defy our current understanding and hint at the existence of other planetary systems. So, the story of our solar system's formation is a tale of dust, gas, and gravity. But what about other planetary systems? In 2017, an interstellar object named Oumuamua passed through our solar system and left scientists scratching their heads. This cosmic interloper, about the size of an asteroid, sported a shape akin to a cigar or pancake. But unlike your garden-variety comet, Oumuamua didn't flaunt a cometary tail or a shroud of gas and dust. Its movements were downright perplexing, leading some to playfully speculate that we had a visiting extraterrestrial spacecraft on our hands. However, the truth, as it so often does, offered a simpler explanation. As the dust of speculation settled, it became clear that Oumuamua likely hailed from another planetary system. It was probably given the boot by gravitational interactions during the tumultuous times of planet formation. Imagine being evicted by the gravity of your own home. But how did it zip through our solar system with such gusto? Well, it was propelled by the release of hydrogen gas trapped within its icy structure, causing it to pick up speed. It's like having a built-in rocket fuel factory. How's that for interstellar travel? Observatories like the James Webb Space Telescope and the Rubin Observatory are our eyes and ears in the cosmos. They're helping scientists learn more about these interstellar comets and what they're made of. The study of interstellar objects like Oumuamua can provide us with invaluable insights into planet formation and extrasolar planets. So while Oumuamua's visit was just a fleeting encounter, it gave us a tantalizing glimpse into the vast universe beyond our solar system. It got us thinking about where we come from and how our planetary neighborhood stacks up against the rest of the cosmic community. Oumuamua's visit was just a glimpse into the vast universe beyond our solar system, but it certainly raised intriguing questions about planet formation. Meanwhile, the Rosetta mission's encounter with Comet 67P revealed some astonishing facts about our own solar system. This celestial wanderer, it turns out, is more than just a space rock. It's a relic, a repository of ancient molecules that harken back to the dawn of our solar system. The Rosetta mission, a pioneering venture by the European Space Agency, was tasked with studying Comet 67P in detail, and it did not disappoint. The spacecraft detected molecular oxygen emissions from the comet's nucleus. Now, this wasn't just any oxygen, it was primordial oxygen, dating back to a time before the formation of the planetary nucleus. This discovery suggests that there are two distinct oxygen reservoirs within the comet. One reservoir, pristine and untouched, lies deep within the nucleus layers, while a secondary reservoir was formed during the comet's thermal evolution. This opens up a whole new understanding of how planets, including our own, might have formed. The presence of this early trapped oxygen indicates that it likely formed during the initial stages of planet creation. It's as if the comet has been carrying around a sample of the solar system's baby pictures for over 4.5 billion years. This discovery is not just about the past, but also about the future. It gives us invaluable insights into the early history of our solar system, helping us to understand the processes that led to the formation of planets. It's like piecing together a cosmic jigsaw puzzle, with each piece we find helping us to see the bigger picture. So the next time you look up at the night sky, remember that each comet streaking across the sky is not just a beautiful spectacle. It's also a messenger from the past, carrying secrets about the birth of our solar system. Comet 67P, like a time capsule, has preserved the primordial ingredients of our solar system, giving us a glimpse into the past. The study of interstellar objects and comets shed light on the formation and evolution of planetary systems, but there's still so much more to discover. As we unravel the mysteries of the cosmos, we find ourselves on the cusp of a new era of exploration. Astronomers and scientists are leveraging cutting-edge technology to delve deeper into the universe. Observatories like the James Webb Space Telescope and the Rubin Observatory are leading the charge. These high-powered telescopes allow us to peek into the farthest corners of the universe, unveiling phenomena we could hardly fathom. They help us study intriguing objects like Oumuamua, the interstellar visitor, or Comet 67P, with its primordial oxygen. By examining these cosmic bodies, we gain a deeper understanding of the processes that shape planetary systems. We learn about the gravitational interactions that kick out interstellar objects, or the thermal evolution that forms secondary oxygen reservoirs in comets. Yet the more we discover, the more questions arise. What other interstellar objects are out there, speeding through space? What other elements are trapped within comets, waiting to tell their billion-year-old tales? How do these findings affect our understanding of our own solar system and of the countless others in the universe? The future of this field is teeming with possibilities. As our technological capabilities advance, so does our potential for discovery. We're not just looking at the stars anymore. We're studying them, learning from them, unraveling their secrets. Yet we must remember that our understanding is still limited. The universe is a vast, complex puzzle, and we've only just started putting the pieces together. There's still so much we don't know, so many mysteries waiting to be solved. The universe is vast, and there are countless planetary systems out there waiting to be discovered. Each one holds the potential to reveal new insights into the formation and evolution of planets. In the grand scheme of things, we're just beginning to scratch the surface of understanding the universe. We've taken a cosmic voyage today, from the perplexing journey of Oumuamua, an interstellar object coursing through our solar system, to the ancient secrets of Comet 67P, a celestial body holding clues to our solar system's infancy. Let's recall the intriguing case of Oumuamua. This interstellar interloper, an asteroid-sized object with an unusual shape, puzzled scientists with its aberrant movements. Yet, the mystery seems to have a rather simplistic solution. The object likely originated from another planetary system and was propelled by the release of trapped hydrogen gas within its icy structure. An intriguing instance of cosmic billiards, don't you think? Then we delved into the heart of Comet 67P, revealing the presence of primordial oxygen. This comet, it seems, harbors ancient molecules dating back to the early stages of planetary formation, offering us a glimpse into the past, a window to the universe's early days. These celestial bodies, these interstellar travelers, they're not just floating rocks or chunks of ice. They are cosmic time capsules, bearing the imprints of their birthplaces, carrying the secrets of planetary formation and evolution. Yet all this is just the tip of the cosmic iceberg. With each new discovery, we unravel a bit more of the universe's grand tapestry, but there's still so much more to explore, to understand. The universe is vast, filled with countless stars, each potentially a sun to another planetary system, and each of these systems will have their own unique stories of formation and evolution. So next time you look up at the stars, remember, each one could be a sun to another planetary system, each with its own story of formation and evolution. If you enjoyed this journey through the cosmos, don't forget to like, comment, and share this video. Until next time, keep wondering, keep exploring.